what I want you to do now is to dive into these three open problems in computer science and algorithms. The first one is P versus NP. Second is fastest algorithm for matrix multiplication, and the last one is the multiplication of two n-digit numbers. And so the first one here, P versus NP, first of all, what I want you to explore is, what is P? What is NP? And what is this question mean, P versus NP? All right, so go ahead and dive into that, see what that exactly means. Try to get a firm understanding of what this problem really entails, because it's really wide. It has a very wide spectrum, and its solution has heavy ramifications for the world as we know it. So go ahead and take a look at that. And we have a week, so I can see you kind of answering these questions in maybe 10 minutes, but we do have a week, so I want you to go ahead and dig and just see how other people or other researchers or other computer scientists, other mathematicians have tried to attack this problem and failed, right? So these are open problems because nobody has solved them, at a level that others feel is possible. So go ahead and just dig as much as you can. And the second open problem is fastest algorithm for matrix multiplication. And Dr. Umans, when he came in during the meeting at the College and Career Center, he spoke about this. Right? He spoke about how matrix multiplication is a log of n squared, has a speed of log of n squared, and the quest is how can we bring that down? How can we bring that down to n log n? Right? Is the golden is the ultimate goal. And he's also went over the fact that there are mathematicians who have brought that down from n squared to n to the 1.99, n to the 1.97, right, and n to the 1.85, and have brought it down. And so the kind of questions that I want you to ask are, first of all, what is matrix? What is it, right? And so that's a kind of an idea that's coming from linear algebra, which is maybe out of reach for, not out of reach, but something that you haven't been exposed to just yet. And then how do we multiply matrices? And then next is, the history of advances in this area. So I would want you to explore and see who were those mathematicians who went ahead and found algorithms that were slightly faster than n squared, and then kind of study, what kind of techniques did they use in order to chip away at that problem, right? How were these advances made, right? So again, I just go ahead and dive into that and see where you come out. You'll probably start with linear algebra, and who knows where you'll end up. But go ahead and wrap your mind around that. And remember, for all the groups here, that at the end of this, I want to have 2 concept map entries per student. And 1 journal entry. And so each concept map entry is going to involve a presentation video, right? And so the idea here is that once we finish up and 2 people take this problem, 2 people take this problem, and 2 people take this problem here, that at the end we can watch each other's videos in our concept map, and we'll have a pretty good understanding of what P versus NP is if I was studying fastest algorithm for matrix multiplication, and I could watch the video here in order to get my head around what exactly that problem entails, right, and some of the history behind that problem. So last one is multiplication of 2 n-digit numbers, and so first of all, we will want to go ahead and describe the problem, history of some of the advances that were made, and the mathematics of how those advances were made. And lastly, the question that I want you to think about as you study these 3 different open problems is, how will solving this problem change the world? Because I can assure you that solving this problem here will change the world. Governments will fall. Literally, right? And if we can get a faster algorithm for matrix multiplication, then that would make huge advances in multiple areas, right? And then we would see that. And so that's kind of what I want you to go over is what what kind of applications would a solution to these problems have, and then how would a solution make those processes faster, and if those processes are faster, then how will that affect how we do things currently, right? So yeah, go ahead and dive into that, and I'll see you on the other side.